Good morning, good afternoon, and good evening, ladies and gentlemen. Welcome to the TCG mcube Day, a day we have marked to celebrate our efforts and endeavors in helping clients across the globe in tapping into our AI platform, TCG mcube 4.1. Today and every day, businesses around the world are operating under constant time and performance pressure in very unpredictable and constantly evolving times. It is a real challenge because with increasing disruptions comes increasing complexity and the need to solve today's problem yesterday. At TCG Digital, we help our clients innovate and successfully adapt to these disruptions to operate more productively and predictably. Today, on the TCG mcube Day, we will celebrate our highly performant platform, TCG mcube 4.1, which is supporting enterprises to catapult their business towards greater success. Over the next 1.5 hours, our expert set of panelists will elaborate our vision and our platform. But before that, I will set the ground rules for the session today. I am Amrita Roy Chaudhary, your moderator for the webinar. To start with, we have put all of you on mute to avoid any kind of background noises. Our panelists will speak first, followed by a short demonstration of some of the solutions we have implemented for our clients worldwide. We will then open up the session for question and answers. You can type in your questions in the top right-hand corner box, and we will direct your questions to the panelists for further deliberations. So, ladies and gentlemen, to bring TCG mcube Day to life, I will request our Executive Chairman, Michael Hagstrom, to set the ball rolling. Michael, over to you.
Hello. Thank you for joining us today. I hope you and your loved ones are keeping safe. We are living in unprecedented times of volatility, uncertainty, and complexity. And it's increasingly hard for any one organization to solve for the complex problems that we face with the time and resources at our disposal. This is also why this is an opportunity to join forces and work together. We here at TCG Digital would like nothing more than to help you prosper from this shift in the market. I read the recent Deloitte report that concluded that 87% of companies think digital will disrupt their industry, but only 44% consider themselves prepared. Today, we will share how we have helped some of those companies that prosper in today's economy. My name is Michael Hagström, and I have spent 30 years in advanced analytics and the AI space, mostly as president of the largest AI platform companies, but also as partner at McKinsey & Company with a distinction in advanced analytics and digital transformation. I've also spent over 20 years with the World Economic Forum, including as chair of the Global Agenda Council. And what we will share today builds on that work, as we will be focusing on the fourth industrial revolution and the most common corporate response, launching a digital transformation program, often to disrupt from within. Today, I have the pleasure of speaking to you in my role as executive chairman of TCG Digital. TCG Digital is a technology leader in the AI platform space with distinction and experience in enabling and guiding clients through the digital transformation journey. That includes through best practice methodologies such as the AI Factory and the AI Labs. TCG Digital is part of a multi-billion-dollar strategy group, employing an impressive array of over 1,000 digital minds, and with links to the Crest University that is conducting leading research in all aspects of digital transformation. That's ranging from quantum computing to leveraging data science and AI to solve real-world problems. TCG Digital is serving some of the most well-known clients in the world with an edge in applied deep learning to help you liquidize the unstructured data assets. And they commonly represent some 97% of the data that any enterprise has. And what makes TCG Digital unique is that it solves for the problem of hardening, industrializing, and maintaining AI applications in production environments. Some recent studies conducted by McKinsey Global Institute reveal that over 70% of the digital transformation program stall. And the reason is simple. What works as a proof of concept doesn't sustain impact in production. And as you drill down, you'll find a large difference between industries on top of the impact list versus those at the bottom, where digital transformation failed to deliver the expected impact. But even the industries at the top of the list only see 50% of the impact potential based on the use cases that are already proven. I will share this list with you in just a moment. As I conducted my due diligence on the TCG Digital customers, what caught my attention was the overrepresentation of clients with previously failed digital transformation programs. Customers that are now the largest customers of TCG Digital and became that after having restarted the digital transformation programs. I tried to find out why. So let me share with you what I learned. The first reason that I found is how TCG Digital solves for the big data problem. Most production use cases of AI are based on one of the 4 AI families that we refer to as supervised learning. And what the word supervised means is that the data must be cleaned, it must be labeled and altered for use. And this process usually represents the majority of the cost. As a result, most of the successful AI use cases are based on well-structured data, such as customer data with a focus on customer service management, pricing and promotion, next product to buy, churn prediction. And while many other use cases, such as predictive maintenance, yield optimization, fraud, and cyber, they often stall as they depend on less structured data sources. And that's data such as pictures or meeting minutes or even high velocity data, including industrial IoT data. The cost associated with maintaining these use cases in production can get high, as you need to continuously manage and tagging that data. And this is where TCG Digital proven to deliver distinct impact by automating or even eliminating some of the data management requirements, both through mcube, the AI platform, but also through best practice AI factory together with its clients. The second reason relates to the rising complexity of maintaining the models themselves in real life production environments, including how to sustain the impact and the lift in the models once you place millions of them in production. This is partly a metadata problem, but you also need AI for AI. You can think of it as a supervisor AI bot that manages all millions of AI bots active in production. Some refer to supervisor AI bots as AI 2.0. These supervisor bots depend on complexity and completely different data, including how to interface between AI bots and us humans. As you know, our current databases and data structures and metadata are designed to help the applications understand the data designed for the machine. But the focus of the AI 2.0 platform is to take this to the next level and help us humans understand the data. And that required completely different metadata and agile augmentation capabilities. But coming back to today and some of the stalled programs, companies rely on open source AI. And they don't necessarily all leverage an AI platform. And what they face is even more basic complexity challenges, as applications often fail to scale due to the complexity involved in just maintaining the code of the AI bots themselves. So take the code base for an open source application. It's commonly 40 times that of the TCG Digital platform-based open source application. Now multiply a 40-time overhead times the number of AI bots in production, and you have an estimate for your maintenance costs. So the problem is simple. The more lines of code you have, the more complex the maintenance. Just writing a predictive use case AI application often costs $500,000 from setting up the environment, preparing the data, and testing. Most of that cost is creating code that you then need to maintain. So writing the AI model itself is usually the smallest part. Ask your teams for the total lines of codes written per use case. And if it's closer to 100,000 than 1,000, you know that you will struggle to scale due to exponential complexity and your program will stall. It results in that your digital transformation program will stall, and that is where TCG Digital stepped in to help with several of its current clients. The third problem I've seen the TCG Digital platform solve for is the impact problem. And this is commonly a gap between business experts and digital experts that hampers the impact. In a recent project, I noticed how the insurance claims experts' way of working was captured into a guided process for picture taking by the policyholder using their mobile phone. And not only did the claims AI bot automate the claims process after an accident and reduce the cost, but it also compressed the claims process and then improved the customer experience. Another example is a recent large industrial digital twin program where the team observed the first principal engineers putting a screwdriver to the rear and the machinery. And this resulted in a collection of complementary data sources through the digital twin. In this case, it was high-pitched sound that the AI bots could pick up much better than us humans. The result was the ability to predict, to prevent, by adding a few low-cost sensors. In both cases, the impact was outperformed any prior expectations. And although it appears obvious that IT and business needs to work together for a digital transformation program to succeed, the reality is that most IT organizations struggle to engage with the business. The reason is commonly the lack of an AI platform that enables them to work in such an agile way that they can engage. Just think of a simple example where you want to move an open source AI prediction bot from AWS to Azure or Amazon. And you need to practically rewrite 100,000 lines of codes as opposed to using the AI platform where it's simply like flipping a switch. And the same applies when adding new data source or a piece of equipment. It seems easy when it works, but it's the challenge of bringing simplicity that TCG Digital has solved for. This particular problem is solved for using the AI platform mcube, and by helping the clients build best practice AI labs designed to enable empowered collaboration. So during the rest of the program, TCG Digital will showcase how the flagship AI platform TCG mcube navigates the digital transformation journey of enterprises and ensures sustainability and business growth. And I would encourage you to also talk to us about the equally important role of the AI factory and the AI lab. If you have a stalled digital transformation program, or you simply want to compare with your current program or plan to start one, either way, we here at TCG Digital are ready to engage. My email address is on the screen. It's my pleasure and privilege talking to you and kick off the mcube day. I'm personally looking forward to enjoy it, and most of all, to learn from your experience. Thank you.
Thank you, Michael, for sharing the TCG Digital vision with us. I will next request our CEO, Mr. Devdas Sen, to share some insights on the showstopper for today, our platform, TCG mcube 4.1. Mr. Devdas Sen.
A very welcome to all of you. It's a privilege on our part to welcome you to TCG mcube Day from my side. My name is Devdas Sen. I'm the CEO of TCG Digital. When we spoke in the last seminar, we talked about the 5 levels of maturity from the automation to the artificial intelligence continuum. The 4th and the 5th level was around predictiveness and cognitive AI. mcube has significantly moved ahead since then. When Michael was talking about predict to prevent, there are several examples that we now have where we are replacing the human cognitive decision-making capability with mcube. For example, there are many cases where we are determining what is the most optimal way in which a large chemical plant could function so that yield is maximum, so that profit is maximized. And in doing so, we are putting a lot of stress on the asset to make sure that nothing goes beyond the parameters, the design parameters of the asset, and something bad doesn't happen. So it's predicted and predicted to a point where it's running at the brim, but it does not fall over. That's where we are replacing some of the human decision-making capability with mcube. Another one is when we are predicting to plan. And when we're predicting to plan, what we are doing is we're replacing transaction capability by mcube. For example, in smart buildings, we are taking inputs from the air conditioner, from the humidifier, from the luminosity of the room, and then predicting what's the right level at which the room should be lit up, what's the right temperature of the room, what's the right humidity of the room, and then determining that and pushing that information back to the switches so that they can be automatically turned on and turned off, hence saving tremendous amount of energy. So what mcube is doing today is we're of course reporting a whole bunch of things, and you'll see a lot of that demonstration in the next few sessions. But we're also predicting to plan, where we are replacing the human transaction capability with the machine. So it's machine to machine. The example that I was giving you was where we are controlling the various facets of the atmosphere in various buildings, replacing the human transaction and significantly saving energy. And then we go on to predict, to prevent. The example I gave was where we are running chemical plants at the maximum possible capacity without something bad happening. So the five levels of maturity, and we can go back to our website to look at that video, talks about the 5 layers of AI, and the top 2 layers is happening in reality for us. So if you look at mcube today, so these are the building blocks. So we can pull data from pretty much anything in real time as well as in batches and put into a polyglot storage, which is we store various types of data in various types of databases, let's say Elasticsearch or a massively parallel processing database or just an RDBMS, depending on what the data type is. And then there's a very, very enhanced, more than 1,000 algorithm enhanced artificial intelligence engine that runs on that data store, as well as the charts, graphs, reports of the business intelligence happens. We also have a very, very sophisticated data publishing layers, which is completely API-fied. And this entire data stream from the left to the right, if you see, can happen absolutely in real time. It happens whether AI is done in real time, ingest is done in real time, and that's one of the biggest powers that mcube is now bringing onto the table. Another thing that I do want to mention out here is that when you take this platform, you do not need to throw away what you've already done. Making sure that legacy investments are leveraged is one of the biggest things that we do. So if you have a code in R, or if you have code in Python, or if you have a code in even SAS, we have the ability to productionize that at a significant scale, making it secure and making it run in a very, very quick and safe manner. So we leverage existing investments, at the same time bring to you a very, very sophisticated state-of-the-art platform. And you'll see a lot of that in the coming hours. And mcube is not just for the business users. So the business users, of course, can do the charts, graphs, reports, self-service. But it is also for data scientists who can write very complex data science code, or it's also for citizen data scientists, where business users with some knowledge of data science would still be able to build out data science model by dragging and dropping a few nodes. And again, that's something that we'll see. From a data management standpoint, there is a very deep capability for the data leaders and the IT leaders, and it's a database or a polyglot storage that can significantly scale and attend to your needs. And finally, the 3 core value propositions that we keep talking about is around computer vision, natural language processing, and IoT and analytics are the 3 critical building blocks of mcube 4.1. And you will see a lot of that in the next few hours. So welcome again to the mcube day, and please stay tuned to hear about all the stories that we want to get to you. Thank you.
Wow, that is quite the versatile and full spectrum AI-driven platform of the future. Thank you, Devdas, for explaining mcube 4.1 so lucidly to us. I'm fortunate to have a very distinguished and esteemed set of panelists joining me next, who will share with us their experience about how the world is leveraging digital and transformative technologies to bring in radical changes in the ways of doing business and thereby accelerating value realizations. On the panel today, I have with me Mr. Sudipta Sen, President for Asia, TCG Digital, Mr. Wolf Lichtenstein, President for Europe, TCG Digital, and Mr. David Cowles, a member of the Advisory Committee for TCG Digital. Welcome to all our panelists. We've had our Executive Chairman and CEO detailing the TCG Digital vision and our platform for us. My question to you, gentlemen, I have more specific questions from the client side of the spectrum. My first question, maybe to Wolf. Wolf, AI and data science are quite the buzzwords in today's analytics industry. And you have been guiding multiple organizations, particularly in the European region, through such implementations. My question to you is that, what is it that drives entities and their management to take up this digital journey? What are the kind of challenges they are facing, which is kind of pushing them towards this digital journey?
It's a pleasure to be in this panel for me, for sure. And of course, my experience is based on clients that are in Europe. On the other hand, I would assume that it will not be so terribly different from other parts of the world. Saying that, first of all, it's interesting that in a study from Accenture that about 84% of C-level people, C-level decision makers are aware of the fact that AI is needed to be competitive. And on the other hand, 74% of the same group think that they are not in a position to scale this. And this is already a challenge I will come back in a minute. So the reasons for using AI, on the one hand, is, as I said, the awareness that it's needed. But why? We are living in a world of hyper competition. And hyper competition means not just the competition you are used from the past, but every day a new company starts up, being agile and moving into your direction. So the old mantra of just being a price leader or a cost leader is not enough anymore. You need also to be very, very fast. And therefore, AI is for sure seen as a dramatic enabler of becoming not only agile, but much faster. And the big challenges that the customers and clients are facing in Europe that are, first of all, from a technical perspective, the huge amounts of data. They were not, to be very blunt, not able to manage that in the past with the old warehouse projects and the system integrators. And it's even becoming more difficult with new data coming around, like voice data, like images, etc. So this is a major challenge where AI obviously can help. Second big driver for using AI is for sure the complexity of problems that cannot be anymore analyzed by people alone. You need machine support. And these two things, I would say, are major drivers and at the same time major challenges to overcome. And when we look now at mcube as a platform, then we see exactly here mcube helps. It helps on accessing all kinds of data, and it's doing it in not only fast, but it's doing it if it's needed, even in real time. So on this, it's a major advantage. A second big problem, and that is the last one, of course, I can speak about this for hours, is the lack of people that are able to bring together business, artificial intelligence skills, and data skills. You can call them data scientists. And also here, I would say TCG Digital not only has a premium product that is doing end-to-end AI, but also is providing the clients with a group of really great data scientists focusing on all these industries where mcube and TCG Digital are active.
Thank you, Wolf. So I hear that, organizations are sitting on a treasure of their own data, and that's where TCG Digital can help them end to end. Most organizations are working in very versatile, very changing, evolving circumstances, and there's no denying the fact that the biggest change in the recent past has been COVID, that the type of changes that it has brought in the ways of operation. Sudipta, for you, my next question would be that, while most countries have taken up aggressive vaccination drives to kind of get back to post-COVID normalcy, but most entities are still reeling and coping with the new ways of working in the post-COVID scenario. How do you see digital transformation in this post-COVID scenario?
Amrita, thank you for a very leading question. And it's indeed very timely considering what we are going through at this point in time. In fact, most progressive organizations across the globe, including in Asia and Middle East, are the ones who have taken on digitalization with a bold, courageous initiative. The devil corona has actually accelerated the adoption of digitalization, primarily because the new way of working, being confined to home, and so on, could not have been possible without the digital intervention. And that's where, be it the ones where probably you and I, all of us have seen the benefits of digitalization, is to have food getting delivered at home, to buying things while being confined at home, clearly was one such scenario. But even in the industrial side of the equation or in other B2B type of engagements, digitalization has played a very important role. To give you an example out of the insurance sector, specifically the motor insurance sector, TCG Digital has played a very important role in this part of the geography by helping our clients to crunch the time it takes in order to do the approval process for any of these claims using the digitalization process. So while doing so, if you look at in good old times, if one had the unfortunate situation of having to deal with getting an insurance claim to be done for a damaged vehicle, an agent had to show up either at the residence of the individual or wherever the garage was, where the car was available for inspection. Post such visit, typically the complete claims processing would take anywhere between 10 to 15 days. Today, no more. The digital intervention that we have provided using the mcube's capabilities of data ingestion, mcube's capability of making use of the hyper contemporary technologies such as using computer vision to using AI and ML type of underpinning technologies. Today, the complete claims process has been crunched to hours. So the system gives the capability in the hands of the end customer to use their smart devices, such as the smartphones, to take the picture and upload it to the site which has been provided by the insurance company. And underpinning capability deciphers whether it is a scratch or a dent. If it is a dent is of what kind of severity, requiring whether a panel change or associated with that panel, whatever be the bill of material, are also pulled out while approving such a claim, which is done within hours. So benefit is huge. So I thought this was one such example where we have seen significant adoption by large number of companies in India as well as parts of Asia and Middle East.
So completely touchless end-to-end management and speedy management. Very exciting, all using our platform, TCG MQ.
Absolutely.
David, I know for one that most of your work is centered around the US market. So how do you see data management, data quality evolve, particularly in the US market?
Great question. Data quality and the importance of data management is continuing to become a foundational importance as we can leverage AI and other business data to be able to create market differentiation, increase our efficiencies and to be able to analyze things in a whole different manner. So for us to leverage some of the new technologies, data is critical to have it at a high enough quality and availability to make better decisions. So without having great data management and data quality, the analytics is useless. They say, you know, bad data in gets bad decisions out. So good data in gets good decisions out. And so it is critical that companies focus on the importance of it. mcube in particular, in my experience, helped us to be able to analyze data at a rapid pace to understand if it was of quality, to be able to use it, to be able to make sure that the analytics could hold up over time and to make better predictions for our users.
Right. Thank you, David. I have a question for all of you. So we've understood, you know, the various implementation perspectives, what we are doing, what can be done, what is the industry doing across the world. Now, what are the kind of benefits that organizations should be expecting? What they should be clear on what kind of benefits to accept. What do you think are the kind of benefits that organizations should be keeping in mind when getting into this digital transformative journey? Wolf, we could start with you.
Yes, I think when you take first of all into consideration that the key for success on AI is on the one hand the amount of data that you can process and the way you process it, no matter what kind of data it is. So if we take that as a given fact, which I can only imagine mcube can do that seriously, and on the other hand, then see in this hyper-competitive world that everyone is doing it, the ones that will be doing AI in a way like a factory. So not just, you know, once in a while, but creating everyday new AI-based processes, new AI-based offerings, new AI-based optimizations. Only those will be the leaders. And to become that means that you need to focus on what is really relevant. And really relevant at the end of the day is only solving the problem. But on the other hand, the biggest effort is to provide data and to provide all the necessary logic. And that is something that is taken away by mcube, and that means that you really have saved a lot of time. And the key then is that you are enabled by yourself to focus on how to solve problems with AI based on this platform, and that by yourself, and not just by, you know, problem-solving stuff from externals. So this enablement, together with the ability to provide the data and to have the people in the company that are able to analyze and use these algorithms, these three things together will make you a leader or a laggard.
Interesting. Shuripto, your thoughts?
Yes, in fact, let me give you the example which I talked about insofar as insurance industry is concerned. The benefits and the results are primarily, one is a direct commercial benefit. For instance, earlier if the agents were visiting the clients, visualize if there are maybe 30,000 claims and each visit of such an agent costs 300 rupees. Here we are talking of an expense of 9 million rupees in a year. So there's a direct saving of the expenses which were otherwise being incurred on doing so. Second piece, which is most important, is the ability of client satisfaction. Today, a client is happier that his or her car is coming back home after being repaired at least 15 days earlier than what probably it would have taken in good old days. And unlike the Western world, where should there be an accident, the insurance company provides a loaner car. That's not the case in India. So India, consumers have to go through the discomfort of not really having a car while they are waiting for the car to show up after repairs. So it's a significant benefit from the perspective of higher client satisfaction to the insurance company. So the third dimension is also the dimension of ensuring that the frauds are avoided, because by doing this, the insurance company has full visibility in terms of what's going on. So therefore, chances of fraud are also reduced significantly. So in terms of benefit, obviously, there are clearly three areas wherein you saw in this particular example, scenario is going to be exactly the same across any other digital transformation that happens. As Wolf said, it is operational excellence, it is commercial benefits, it is making the processes so much more convenient, easy, simpler to be done. And that eventually leads to high degree of client satisfaction as well as adding to their EBITDA.
Thank you. David, your thoughts?
Yeah, every company's journey is different, but as we look at monetizing data or optimizing metrics, having strong data management, data quality is the necessity to make those journeys successful. The importance about the ability to stitch it together and to have abilities to analyze the quality of the data is a must as you look at the cost of creating the data sets and analyzing them. And again, my experience with looking at mcube, it helped us in that area because it was able to give us the means, the mins, maxes, the gaps in the data, so that we could actually determine if this data set could make the predictions or fulfill the hypothesis that the business user proposed.
Right. Thank you so much. Thank you for the interesting deep dive into the real market-facing experiences. Thank you, gentlemen.
No problem.
Our next speaker, our Vice President, Mr. Amitabh Sinha, will take us through the application of artificial intelligence in TCG MQ 4.1.
Good morning, good afternoon, and good evening, depending on where you are. Welcome to this session. I'm going to take you through the capabilities of TCG MQ, the platform, on the data science part with plethora of artificial intelligence and machine learning models built in, which can act as great accelerators to help you solve your data science problems. So let's get started. At the outset, let me give you a little brief on what the data science journey looks like. This is how a data science journey or a life cycle looks like. So it starts off with a problem definition. Then there is a business understanding or correlation to the problem. And then the problem needs to be defined with respect to the data that would come in. And the data needs to be properly explored, the missing data elements treated, outliers detected, the independent and dependent variables segregated, so that the data set is absolutely ready to start off with your data science journey. Now, once the data is ready, then you need to find and then what are the different numeric data elements which are there, the different non-numeric elements which are there, basis which you need to do some feature engineering. The non-numeric data need to be beamed or converted so that they can be used in the model creation. Now, then you start creating the models. You can have a single model, you can have multiple models. For example, you can have a classification problem to solve, or you can have a regression problem to solve. So basis which you will pick up the different models. And then you'll have to split the data that you have acquired into a test and a train. So the train data set will be used for training the model, fine-tuning the model, and the test set would be used for testing the models. And then once you are happy with the performance of the model, so the model is ready for deployment and the model can be deployed into production purposes. Now, once the data is there in the production environment, you might find that the baseline in which the model was built is changing, which means you need to revisit the baseline. So the models typically are of two types: supervised learning-based models or unsupervised learning-based models. In supervised learning-based models, you need to manually fine-tune it and then supervise the learning of the model per se. But it is unsupervised learning, so then the model will have the ability to learn by itself. Right? The whole point is that once you create the model needs to retune or refine itself either through manual intervention or automatically as and when the baseline shifts. Then your model will become relevant with respect to the changed data. And then the model will, of course, generate certain insights, certain call to actions, which can be visualized in different formats. It can be very simple KPI dashboard reporting, or it can be some call to actions using some, like prescriptive analytics, etc. Okay, so that's a life cycle of a data science problem. Now, let's see how does this get fit, or how does this get delivered out of the mcube as a platform. So we are in the advanced analytics section of mcube. So this is the data science part of the mcube as a platform where you can go and build different data science models using different techniques. What I'm going to take you through is the different accelerators which are there as part of the platform, which can be used to create these different data science models to solve the different problems that we just talked about. On the left hand side, you see there are data sources where you can go and select data from the library. If it is already there, you can connect to different databases where you can get the data from. It can be from external files or HDFS or even Google spreadsheet. Look at the flexibility of the platform. Once you get the data in, so basically you can actually go and read the data. For example, here we are reading the data from a particular library. So with the data coming in, then you can actually go and do a lot of operations on the data. So you can do a join, split, union, sort, etc. And not only that, what you can also do is you can actually do different kinds of transformation in terms of, for example, if you want to do an SQL transformation, you can do it here. If you want to do a custom Python transformation using a Python code, it is available. You're familiar with R transformation, you can do it as well, right? Now, if you see this example here, we're trying to do a very simple linear regression. So how do you differentiate between a regression and a classification? So regression is where you are trying to predict the percentage of the output, whereas a classification is just like stating whether the event will happen or not, right? This is a regression problem where we are taking in the data, and then, for example, if you look at it, the data goes through certain preparations. As I was saying, that you need to go and convert the string variables to numeric variables, so on and so forth. And then finally, you split the data into two halves, one for training the data and one for testing the data. So obviously the training data set has to be higher. So in this case, you have done a 70-30 split. Now then you go and start with the model. Now the beauty of this platform is, if you look at it, we understand this is a regression problem, and on the regression side, you have all these regression models built in. For example, you have linear regression, you have decision tree regression, you have GPT regression. Now, how easy it is to go and try out different models? As simple as that. So you just, for example, you remove this. Now you can actually go and work on three different models, and it is absolutely drag and drop, which means this is now the model that is going to use a linear regression model. And then you actually train the model, and then you run the model using transform and prediction. And then how will you know that what is the behavior of this particular model? So we have built-in evaluators as well, which is like your regression evaluator, which can be used to evaluate. So now if you're not happy with the evaluation, then of course you can try another regression model. Okay, and then you do the same thing. You do the transform, the prediction, and then again you can actually go and evaluate it, right? Similarly, if let's say you are not happy with the decision tree regression as well, then you can use the gradient boost tree regression to do the same thing. So that's the power of the platform. So you can play around with multiple models just on the click, drag and drop, as simple as that. Now let's look at a slightly advanced problem statement. So this is an example of basically an optimization problem. So here we are trying to optimize the yield and margin of refinery. So here we are doing the same thing. So we are using the read data to read from different sources. These are your real-time sources. And then what we are doing here is we are doing custom transformations using Python, where we are removing the outliers, the missing value treatments, and for example, date transformation, right? So all being done here. So if you look at it, this is a very simple low code which is generated by the platform, where you can do the missing value treatment, so on and so forth, right? Now, once the data is ready, so you are joining the two data sets, and then once your data set is ready, you are ready to start off with the models. So another transformation here. So here what we are doing is we are basically predicting, right? So here we are trying to predict the output that is coming in from different. So in this case, there are 5 different product state outputs. So for example, this is one of them, which is the lower naphtha, and then there are higher naphtha, so on and so forth, heavy naphtha, lighter naphtha, you have kerosene and diesel. So best part is in this case, if you see the selecting the best features, right, to be able to go and do a prediction can be easily defined out of the box. And then once the prediction is available, then there are 2 different tracks that one can take. One can go ahead and do a margin optimization, or one can do a yield optimization. So again, absolutely easy. You can actually do a drag and drop here, and then you can go and create the models here. So see, this is a plethora of models which are available, right? So in this case, we are talking about basically a prediction. So you can go and work with the recommendation, or you can work with basically the classification as well, that whether this will be an improvised output or it would be a normal output. So even if you look at this yield optimization, we are trying to increase the yield. So here we are working on different combinations. So for example, the combination of diesel with respect to heavy naphtha, combination of heavy naphtha with respect to lighter naphtha, so on and so forth. And then all the constants can be superimposed here, right? These are coming in from vectors. And finally, you have an output which gets generated, right? So this is what the model does with respect to yield optimization. And then once the model is ready, the output can be saved for purposes. Similarly, if you have margin optimization, the margin optimization will take care of improving the profitability, the overall profitability. And the overall profitability will be calculated without any constant. In the yield, there would be a target that you need to optimize the yield of a particular product slate output. But in this case of a margin, you don't have that constant. So it is purely taking in the financial figures, right? For example, the price of the raw material vis-a-vis the selling price of the output. And we are utilizing these data points to calculate the overall profit margin. Okay. So while this is very complex, but you see how easy it is to do a drag and drop and create the model. So this is hydrocracker optimization. Let me show you a different kind of a problem statement that is also solved using the platform, and again using the accelerators which are built in. So if you see here, what we are trying to do is we are trying to do an inventory optimization. So which includes spares, right? Optimizing the spares, which means reduction of the dead stock, reduction of the inventory holding, optimizing the reorder level, optimizing the economic order quantity, so on and so forth. So in this case, if you see, we read from multiple sources. Okay. So somewhere we have the spares data, somewhere we have the inventory data, somewhere we have the demand data, somewhere we'll also taking data for the suppliers. For example, what is a lead time, so on and so forth. So the same process where we do the different joins and we write transformation codes. But finally, what it does is here there is an element of artificial intelligence which comes in, where we use something called a Jaccard similarity to basically go and find out the different groups which is already there. Okay, and then find out that these are the set of spares which are absolutely similar in nature, but they have different nomenclatures. So it has to be sensitized. So this is one part that is being done with an artificial intelligence model called Jaccard similarity. And then using the machine learning techniques of, let's say, prediction techniques, where you predict that, what is the optimum number of inventory. For there, you use something like a reorder level, ROL, or a min-max kind of a model to be able to go and work with it. So this is a very low kind of a, data model, which is very low code, which is getting generated, and it is absolutely configurable. So the whole idea is a very complex problem like an inventory optimization can also be, you can see a lot of nodes here, but this is absolutely, linear flow one by one. And then there is a coagulation that is done to finally, arrive at the objective, which is your optimized inventory stock with the right set of economic order quantity, safety stock, reorder level, so on and so forth. I am handing over to my colleagues who would take you through the next set of use cases. Thank you.
I will now request my colleagues, Panchali Roy Chaudhary and Akhil Vaswani to take us through some of the solutions that we have implemented for our clients worldwide.
Today, we're going to walk through the WatchSafe solution powered by TCG mcube. WatchSafe leverages deep learning-based computer vision algorithms to analyze live feeds from multiple cameras and generate event logs and non-compliance alerts in real time. As a part of the WatchSafe solution, we have several capabilities. We can perform people detection to track how congested an area is, monitor the traffic flow, and detect and locate and count the number of people. We also track social distances, making sure people are 6 feet apart, which is especially important during this new COVID era. We track violations across frame by frame to determine a discrete count of events. These events are based on time and logged after each session. Overall, we can perform object detection and tracking. Again, this is very critical. Whether we are referring to tracking factory workers wearing their safety helmets or employees wearing masks in a retail outlet, using our deep learning algorithms, we can track this seamlessly to drive value to the businesses. Finally, we can perform facial recognition, which enables facial identification for known individuals and reports alerts for unknown individuals. In a security surveillance situation, if there is an unknown person coming into a work area, they can be tracked and monitored. Frame by frame, we apply the deep learning algorithms to drive surveillance insights. And now, I'll give you a quick glimpse of some of the features of the WatchSafe solution. On this dashboard, we can track social distancing and mask detection. If we look on the left-hand side of this dashboard, we are tracking whether individuals maintain social distances. You can see that there is a blue grid overlaid on top of the video. That is a result of a homography, which transforms 3D real-world distances to the flat 2D image distances, which enables accurate distance measurements and social distance tracking. In addition, when two people are talking close together in the same area, they are breaking social distance norms. This results in red boxes encircling them. When they are walking away from the car, they have green boxes around them, indicating compliance. Apart from monitoring social distance compliance, we also track the number of people in the frame, shown in the top left corner as predicted count. This can be used to apply an occupancy-based social distance compliance and track crowding in spaces like cafeterias, malls, or others. Note, the camera views can also be divided into zones for more granular compliance tracking. On the right, we see a typical mass detection scenario. This can be useful to track compliance in a public location as well as for offices, stores, and others. We can see that people who are wearing masks have a green bounding box, while people without masks are marked with a red box. The dashboard can track every violation of a configured compliance rule or any anomalies. The relevant image frames get stored for future audit purposes. In these tough times of COVID-19, the WatchSafe solution can help create safer environments through maximizing safety and adhering to compliance guidelines. Thank you and stay safe.
Hello, everyone. Now I will walk you through a very interesting use case. This is about expediting patient recruitment by NLP-driven patient-to-trial matching. So we have leveraged our platform TCG mcube, and we've used our data science algorithms to develop a patient recruitment application. In this COVID situation, all of us are now very familiar with clinical trials, right? So, and we all know how important it is for these trials to finish off quickly so that the medicine can come to the market sooner. It's also important that even from a pharma company perspective, they want to finish trials faster because they want to save costs and they want to also increase the access to experimental therapy. Now, to do this, every trial has a set of inclusion-exclusion criteria. which is a long list of texts that exists. And for a patient to enroll in a particular trial, he must be fulfilling that inclusion-exclusion criteria. Now, what we have done is we've gone to a repository of clinical trials information, clinicaltrials.gov, and we have extracted information around the inclusion and exclusion criteria of many different trials. For example, we've looked at non-small cell lung cancer trials, we've looked at prostate cancer trials, we even looked at COVID trials. And we've gone through the 500s of, I think some 500 NSCLC trials or some 1,000 COVID trials, and so on. Now, once we have looked at this information, we have used text mining techniques on that inclusion-exclusion criteria to come up with a superset of these criteria for specific disease areas. Similarly, we have also used our NLP engine on the patient data and the patient treatment data to come up with attributes for the patient. Now we have a matching engine, and this matching engine looks at the standardized inclusion and exclusion criteria for a specific trial and tries to match the relevant patient pool from the patient information. And now this is going to be very, very beneficial for the pharma companies as well as the physicians. So the pharma company can enter specific study details, try out different what-if scenarios, and try to see what is the matching patient pool. The physicians can come in, and if they have a specific attribute of a particular patient, they can try to find out what could be potentially some of the matching experimental studies. Now, I'll walk you through a little bit of the NLP engine that we've used here. So as you can see in the schematic, we've taken in clinicaltrials.gov data, we've taken in the patient data, and as a first step, we've done a pre-processing and standardization. And as a part of this, we've done tokenization, lemmatization, stemming, acronym normalization, and so on. At the heart of it, there are many medical dictionaries that we've used. And these dictionaries cover therapy-related information, drug-related information, other medical terms, and synonyms, and so on. So once we've done the pre-processing, then we go into the processing stage 1, where the focus is a macro understanding of these criteria or the attributes. We've used regular expression to parse these text items. We've also covered part of speech tagging and dependency structures. As a phase 2 of the processing, we've also looked at facts, entities, and their interrelationships using certain text similarity based approaches. And finally, we have the matching engine, which facilitates the patient to trial matching. We also have a feedback loop built in, where over time, as we use this matching engine, the matching and the processing becomes even more accurate with time. I will now go over and give you a brief demonstration of this particular solution. As a first step, I'll log into the application. So we get started. So we can browse different trials that exist. So for example, if I click on browse trials and I want to understand what kind of clinical trials are going on in which areas as per clinicaltrials.gov to see what is the spread across different geographies, I can go in and select a particular trial. So let's say I'm interested in infectious diseases and as a condition, we are interested in, let's say, COVID. Okay, so this gives me a layout of all the different COVID trials that are currently ongoing. We can zoom in and zoom out on different areas. We can look at the different sponsors who are doing different COVID trials right now. So let's zoom in over here. Each of these dots are on specific zip codes, and it gives me the names of different sites and the associated studies that are ongoing. So the NCT IDs are, each NCT ID represents a specific study in that particular disease area. And we can go full screen and zoom in and zoom out. So as you can see, if I look at the Chicago area, we have around 8 studies ongoing across 5 sites with a total enrollment of 103 patients. And we can zoom back in, and there's a lot of activity going on the East Coast. There seems to be a center over there. And I can zoom into specific points and specific zip codes over there to understand what kind of COVID trial activity is going on in specific areas across the geography. Now, this gives me a wide overview of all the different COVID trials. Now we get down to a granular level of inclusion-exclusion criteria associated with each of these trials. So now if I go into a design trial mode and choose the COVID template, we see a wide assortment of criteria over here. Now, this set of criteria has been derived by going through thousands of trials from clinicaltrials.gov and applying our NLP engine on the inclusion and exclusion criteria set of those trials. So we have inclusion and exclusion criteria related to autoimmune disease, the disease history of the patients, the hypersensitivity, the age, the exposure, indications, different procedures, different medications, other infectious disease that the patient might be infected with, if there are any liver diseases. So all of these are different criteria that have been specified in one or more COVID trials. And this is like a standardized superset derived by applying the NLP engine. Now, to design a new trial, let's say I have access to standardized patient information, and we have some 15,000 patients in our repository. Now, I want to understand by designing a new trial. Let's say I want to design a trial using a Crohn's disease as a precondition with a disease history of CKD. Let's choose a hypersensitivity parameter here. Let's assume that the precondition is a cardiovascular disease and the minimum age of the patient has to be 18. And we click on the search button over here. Once we submit that, the matching engine now runs and tries to match the standardized attribute with the patient level information. It's now going through each and every patient details and finding the standardized attribute of the patient to come up with a match. So now we see that out of those 15,000 plus patients, only 69 fulfill this particular criteria. We can get even more restrictive. So for example, I might say, okay, the patient has to have all these inclusion criteria, and in addition to that, should not have acute respiratory disease syndrome. So I choose that as an exclusion criteria. And I go back and submit my results again. So when I do that, it's again taking into account this additional criteria and going through the different patient attributes again to give me the new set of match. We are using Spark as a mainstay of our platform. So that's why even on very large data sets, we get a very fast response. So now we see we are down to 50 patients. Now, if we want to understand the geographic spread of those 50 patients, we can do a deep dive here. And we can see, okay, these 50 patients primarily on the East Coast, and we can zoom in and get to the individual zip code locations of these 20 patients. And we can also get the gender and race distribution of these patients as well as the age distribution. So in this way, we can try out different scenarios to understand what kind of matching patients we are getting as we select different sets of inclusion and exclusion criteria. And this will help me design trials in a way such that the trials fulfill the requirement for a particular protocol and also do not become too restrictive. Because if a trial design becomes too restrictive and we do not find enough patients, then the trial will take a long time to complete or may not even complete because they'll not find adequate number of patients. So this is one of the examples where the NLP engine can come in really useful. And this, as I mentioned, this is in today's age, this is a very exciting application as we all talk about the importance of clinical trials. We will now go through a use case on IoT or ITOT. This is a remote monitoring solution that is live across multiple facilities. And what you see here on the screen is an entire battery limit of a plant, providing a comprehensive view of the plant operations, giving us real-time insights as a part of the remote monitoring of plant facilities. We are capturing 15,000 plus tags or data elements that come in from different sources: the historian, the DCS system, and different sensors. So whether it could be an energy sensor, it could be weight sensors, it could be flow meters, and so on. This is a level 0 monitoring view of a petrochemicals plant. So on the left-hand side, you have the naphtha cracker unit, and you can see all the naphtha tanks, and you can also see the different weights, different volumes coming out here. You can see different KPIs being reported. So some of the KPIs directly come in as inputs, such as the feed, whereas some of these KPIs involve real-time computations on the input data. For example, the yield is a computed KPI, and so is the P/E ratio. So all this gets refreshed on a real-time basis. And you can also see some of these KPIs in red. For example, you see the extruder load here is tagged in red. This is because we are able to track whether the KPI values are within a certain operating curve. The operating curve typically lies between the upper and the lower specification limits. And whenever a KPI goes beyond what's set in the operating curve, if there's any deviation, it is highlighted as a part of the solution. Alerts are triggered, and you can have different actions configured along with this particular alert. We can choose to drill down on from this level 0 view. So let's go into a level 1 view of the naphtha cracker unit. So as a part of the level 1 view, this gives us the details of the subplant and covers KPIs related to operations, maintenance of equipments, production, quality, power, and utilities. For example, you can see which of the equipments are up and running. You can see decoke air is down. That's why it's in red. You can choose to do a drill down here. So when you drill down, you can see further details for decoke air. You can track performance across different months. Do the trend analysis, and also do different root cause analysis. And these insights can help in preventive maintenance activities. Going back to our level 1 view, you can look at production KPIs, such as the yield, the P+E, and the feed. You can also look at the material balance. If you choose to drill down here, you can look at the trends across different months and do a month-on-month analysis. This can give you further insights. Going back, we can even do a tag level analysis. So on the tag level analysis, all the different tags which are coming in, we can still select a few tags and try to look at the trends of these tags and also do a tag level correlation. For example, let us select a few tags here. So I select one, and you can see the trend across time over here. Let us select one more. So we add one more tag over here, and now you can see both the tags displayed across time. You can find correlations between these tags. If you want to zoom in on certain time periods, you can do that using the slider very easily. And this makes the user have a comprehensive view about what is happening in the plant. And all this is possible using the power of TCG mcube, which facilitates the real-time ingestion of data from different sensors. Helps us depict that in very intuitive dashboards and perform all these real-time calculations to help the user deep dive on any aberrations or anomalies. Thank you, everyone, for your time. I hope that through these use cases, we've been able to highlight the power and the possibilities using our platform, TCG mcube. Thank you.
Thank you, Akhil and Panchali, and thank you to all our esteemed panelists. We will now open up the session for question and answers. On the question answer panel, we have our Vice President, Mr. Amitabh Sinha, and our Senior Director, Ms. Panchali Roy Chaudhary. So I'll quickly lay the ground rules once more. So all participants can share in their questions by typing the same in the top right corner box. We will direct the questions to the panelists. Panelists will try and answer as many questions as time permits. So ladies and gentlemen, your questions, please. And as I speak, I think we already have our first question in. So our first question is really about how does TCG mcube as a platform accelerate building new spaces to different domains? Amitabh, would you take that question?
Sure, Amrita. So mcube as a platform, it has different models already built in, as I was showing you during the demo that I was doing. So for example, if you talk about the retail industry, so you already have demand forecasting models built in, right? Now for a specific SKU, you need some fine tuning, but the basic model is already there. So what it does help you that it's not really a greenfield development, it's brownfield, it's just a configuration. And with the necessary configuration changes, you can actually do a demand forecasting. That's on retail side. Now let's look at inventory optimization. So inventory optimization is applicable for any manufacturing industry where you have a lot of spares, right? Now, depending on the kind of the spare, so you need to do some fine tuning. But as I said, the basis model is already there. So it's just about fine tuning and configuration, and you are ready. So that's how mcube can act as a great accelerator in dishing out different data science-led solutions for different domains.
Thank you, Amitabh. And we have our second question in as well. So I'll read that out as well. What is the journey from model creation to productionization in mcube? A very good question indeed, because we've been hearing so much about how to build models, so very good question indeed. Amitabh, maybe you could answer that one as well for us.
Thank you. Yeah, I'll do that. So while I showed you how to create the models, and it is so easy to do and drag and drop, so the model by itself, is useless if you can't productionize it, right? Now mcube has that feature because a model would need a data pipeline coming in where the data would come in, right? That's number one. And number two, the model needs to execute real time, take in the independent variables, work on the dependent variables, and give you the insight or the output which can be used for any decision making purposes. Classical example of how this can be done in mcube is you have a full scheduling mechanism, which is like you just click 1, 2, and 3, and the model is absolutely ready. It is scheduled to run at predefined intervals, or it is run on the trigger event. For example, for a specific SKU, you want to do a demand forecasting. So let's say the SKU reaches the reorder level. So automatically the demand forecasting model can be triggered so that the appropriate quantity can be predicted or forecasted by the model right there. So it's absolutely scheduling can happen on just a click of a button. So that's how the models are productionized.
Right. Thank you. I will quickly move on to our next question. So yes, and our next question is, what are the accelerators on the different data science model? Panchali, could you answer that question for us?
Sure, thank you. So, our platform, TCG mcube, the data science model, it has many accelerators. To start with, we offer a low-code GUI-driven interface where you can drag and drop different pre-configured nodes to build out your advanced analytics data science models. And also on top of that, you have different templates which you can save, and you can clone those templates so that you don't have to start building a model from scratch. Now, this saves significant time. Another part is the evaluation of models. So mcube offers certain evaluators which you can very easily access to understand the performance of the model. And again, all this is driven by a low-code drag and drop interface, which really expedites the building of different data science models.
Thank you, Panchali. Okay, moving on to our next question. a minute. So yes, our next question says that how does the life cycle of a data science model get maintained in MQ? Amitabh, I'll go back to you for this question again.
So what is very important in creation of any data science model is a model is relevant with a particular baseline of the data mostly, and then baseline of the particular business logic that is relevant at a particular point in time. And you go ahead and productionize it, as I was explaining, like 3 steps, done. But what you also have to keep in mind is that the baseline data may change. We call it data drift, right? And hence the model will stop behaving the way it used to behave. So which means the data drift analysis needs to be done, that the baseline is changing, and hence the model drift analysis also needs to be done. And beautifully, it is actually taken care in the mcube itself. So you can do a full life cycle management of a particular model. So whenever a model is not behaving as per the expected baseline, right, the expected accuracy level, okay, so you can always do a model drift analysis, you can do a data drift analysis. And if this is like an unsupervised model, the model will fine tune itself. It's like the model will learn on its own and then correct itself. If it is a supervised model, so which means you need some intervention to be able to tune it. But the point is, so the model can be then rectified either through manual intervention or automatically, and then to be able to perform in the chain scenarios of data and the chain scenarios of the business understanding. So from the creation of the model to changes because of a drift and then subsequently making it fit to be able to further go and deliver in the chain scenarios is all available part of the platform itself.
So basically what you're saying, even post implementation, whatever changes, the model learns on its own and takes care on its own. Is that what you're saying?
Absolutely. If it's unsupervised learning, definitely the model will identify the drift of the data, identify why the deviation is, and will go and fine tune itself. Adjust the weightages, change the parameters, and then fine tune itself, and then start delivering to the expectation.
Wonderful. Great. Okay. So good to know all of that. And I'll move on to our next question. So our next question is, what are the accelerators on the data exploration side in TCG mcube? Panchali, could you take that question for us?
Yeah, sure. So on the data exploration side, see, data exploration is a very integral part of starting any kind of analysis or model building. And in our platform, we have out-of-the-box functions which help us. So these could be in the area of in the nature of a data profiling module. So our data profiling module quickly helps us analyze different fields of the data to understand for numeric data, what's the spread, what's the dispersion in the data, or what's the measure of central tendency for numeric fields. For non-numeric fields, we can track how many null values there. We have ways to explore and understand the extent of the data, to understand if there are outliers, if any. So the data profiling and data quality modules that we have in mcube really helps us achieve all of this. And just one more thing I would probably want. Sorry.
Sure. Please go ahead.
We have very, very strong self-service capabilities. So, the user can explore the data on their own, and this empowers the end user a lot, which plays a significant role in, why the users love our platform.
Basically, all these features will also help to reduce the level of manual effort that gets in when we get into the data exploration, right? The platform takes care of itself, of all these things, right?
Absolutely.
So we have our next question.
What's most important, Amrita, is if you look at it, it also expedites the whole process, right? It does reduce the manual intervention. It also expedites the process. Yeah. We keep talking about the go-to-market. How soon can you solve the problem and go to the market, right? So the facilitators, the accelerators help you to do your go-to-market quickly. That's a great advantage of the platform.
And we've heard of the accelerators both on the data exploration side as well as on the data science side, right? So yes,
That's
of course. So we have one more question. Our question reads that model predictive control, how can one utilize that in MQ? Amitabh Panchali, Amitabh, would you want to take that question?
So what was the question? Amrita, just come back again.
Sure. Question reads, model predictive control, how can one utilize the same in MQ?
So this is something that we are toying with this idea. So this model predictive controller is a AI variant of the APC, right? Automated process controller, right? So what happens in a real-time optimizer? So real-time optimizer is an open loop. So in order to make it a closed loop, so that the recommendation by the RTO can be fed into the DCS, so that the DCS can go from the current set point to the desired set point. You can use an APC, which is an advanced process controller. So there is an AI equivalent to it, which is the model process controller, the model driven process controller, which is fairly an AI model. So currently we are in the process of building such an approach. So it's in the pilot stage now. So we have built the model. So we are now in the, as we say, it's like a cold trial. So we are working with the cold trial data. Idea is very simple. So it's a model, of course. It's an AI model. It's an ensemble model, of course, because you cannot have one model, but a combination of several models. And it is trying to do the same thing that an APC would do. From the RTO, the recommendation will come that this is the current state and this is the desired state. So what are the different step function it needs to go through? So it's a fairly complex model because it takes into consideration the first principles in which the plant would operate. So if you're talking about a DCS, so in this case, we're talking about a furnace model, right? So the furnace would have its own kinetics principle. So here, this is a classical problem where you are combining artificial intelligence with the first principle or kinetics model to be able to, state the DCS that this is how the state changes can happen, right? So yes, we are in the process of developing it. We are going to start the cold trials, as we say, very soon.
Excellent question, because I think it's very relevant. As Amitabh said, we are in the pilot stage of building it up. So yes, very relevant questions. And we are actually getting a lot of questions, but I think we are running out of time, and I believe that is all we can have time for today. But ladies and gentlemen, we will answer all your questions. We will have our panelists answer all your questions after the webinar. We will reach out to you. So thank you so much. Thank you to the panelists, and thank you for everyone for joining in today's webinar, today's TCG mcube Day, and what a day it has been, our very own showstopper, TCG mcube 4.1. Thank you so much. Thank you for joining in. Thank you, ladies and gentlemen.